Welcome back guys, I hope all of you will be fine. So in today's video we will try to solve the relevant questions of chapter 4. So these would be question 4.6, 4.7 and 4.8. Okay, so let us start our video by solving question 4.6. Okay, and so the statement of it is an attendant at a car wash is paid according to the number of cars that pass through. Suppose that the probabilities are 1 by 12, 1 by 12, 1 by 4, 1 by 4, 1 by 6 and 1 by 6 respectively, that the attendant receives $7, $9, $11, 13, 15 and $17 between 4 p.m. and 5 p.m. Okay, so the amounts have been written here and the probabilities of getting this much amount has also been given, okay, respectively. So we have to find the attendant's expected earning for this particular period. So in finding the expected earning, we have a formula, and previously we have seen that this is called the expected value. So expected value of any random variable x can be found out by writing the value of a random variable, multiplying it with the probability it has. Okay, so this is what for a single random variable. If we have the multiple random variables, then we have to find out the expected value of it by writing the first random variable, multiplying it with the probability it has, and adding with it the second random variable, multiplying it with its probability. Okay, and then x3 px3. Okay, until and unless we will reach the last random variable, that would be x of n. Let me write it. Unless and until we will reach x and p x of n. Okay, so this is what this is the expected value of a random variable. Okay, so on the basis of this, let me solve question 4.6. Okay, and the solution of it is here. Okay, it has a solution and we have different values of the probabilities, which are 1 by 12. Okay, so let us find the expected value of a random variable x, and we have probabilities which are 1 by 12 of what, that is of 7. Okay, $7. Similarly, 1 by 12 of 9. These are the what, these are basically the, let me write them here. This is 1 by 12 is what, this is the probability, and here x1 is this 7. This is the value of a random variable. Okay, so I hope you have understood that why am I writing these values here. So 1 by 12 multiplied with the value it has, that is 9. Okay, also the 1 by 4 multiplied by the value it has, and that is 11. Okay, and again 1 by 4 multiplied by the value, that is 13. Okay, the next one is 1 by 6. So 1 by 6 with the value it has, and that is 15. And the last one is again 1 by 6 with the value it has, and that is 17. Okay, so this is what, this is the formula which we had here, because here this is, this is px1, this is px2, this is px3, px4, px5, px6, while this is x1, x2, x3, x4, x5 and x6. Okay, so let me take the LCM of these quantities, and the LCM of it would be 12. Okay, and it would be here 12. 1 by 12 multiplied by 12 would be 7 plus 9. Okay, here it would be 1 by 4 multiplied by 12 will be 3. 3 multiplied by 11 would be 33, plus 1 by 4 multiplied by 12 is 3, multiplied by 13 would be 39. Okay, plus 1 by 6 multiplied by 12 is 2, multiplied by 15 is 30, and the last one is 1 by 6 multiplied by 12 is 2, 2 multiplied by 17 is 34. Okay, so these are the values I have. So now writing them here, I will get 152 divided by 12, and ultimately we will get here 38 divided by 3, which is the answer of question 4.6. Okay, and that is the expected value it has. Okay, so this was what, this was question 4.6. Okay, now let us proceed to question 4.7. Okay, and the solution of it we are going to write it here, and let us go through its statement. So by investing in a particular stock, a person can make a profit in 1 year $4,000 with probability 0.3, or take a loss of $1,000 with the probability of 0.7. Okay, so 1,000 loss, a loss of 1000 has a probability of 0.7, and a profit of 4000 has a probability of 0.3. So let me first write this data, and here uh, profit is also written as a positive value because this is always positive, so it is positive, and it has a probability of 0.3. Okay, also we have a loss of 1000, and as this is a loss, so I have to write it with the negative value, and it has a probability of 0.7. Okay, so this is a given that I have written. What is this person's expected gain? Again, to find the expected gain is basically the expected value. How can we find it out? This would be what? This would be again E of x, and by using the same formula where these are basically the values and these are the probabilities, let me multiply the values with the probabilities. Okay, and at the end adding them together. Okay, so let me calculate it. So 4000 multiplied by 0.3, it would be $1200. Okay, and also this 1000 multiplied by 0.7, and this is as negative, so it would be minus 700. Okay, so subtracting 700 from 1200, we will get 500, so it would be 500 USD, and this is a profit of 500 USD, which is the answer of question 4.7. Okay, and that is the solution of question 4.7 as well. Okay, so you have seen that it is very easy to calculate the probability or expected gain out of any business if you have the probabilities of the profits and loss as well, and this is by using this formula. Next question is also relevant, so let us go through its statement first. So the statement of it is, suppose that an antique jewelry dealer is interested in purchasing a gold necklace for which the probabilities are 0.22, 0.36, 0.28 and 0.14. Okay, so let me first write these probabilities. So 0.22, uh, 0.36, okay, 0.28 and 0.14. Okay, so these are basically the probabilities given that she will be able to sell it for a profit of $250, sell it for a profit of 150, break even, or sell it for a loss of $150. What is her expected profit? Okay, so as their values are also given, let me write this. 0.22 is for $250 profit, so it will be positive. Okay, this is 250. This 0.36 is for $150 profit, so it will be 150, positive 150. This 0.28 is for give break even, and break even means that he is neither getting a profit nor a loss, so therefore here I have to multiply it with 0. Okay, and at the end this is 0.14 for a loss of 150. Okay, and in previous question we have seen that for a loss you have to write the negative value with the value of a random variable, so it would be minus 150. Okay, and at the end what do I have to do? I have to add these values together for the expected value. Okay, so I have to add them all together, and in adding them all together, what will you get? You will get 88 USD, which is basically the solution of this question which we had here. Okay, so the only part here was basically writing the negative values with the losses, positive values with the profits, and also zero value with the break even values, and this is what this is again the expected value of x or expected profit. Okay, so that's it for today, in which we have discussed some relevant questions of chapter 4. If you have any question, you can ask me in the comment box. See you soon.